So then you've got your cute, hungry little client web browser that sees all of those DOM nodes, and it goes, I'm gonna eat those right up. So if you want to learn like your 5, let me see what I can do here. So this is opportune because I actually gave a talk last week on this.
Yay.
It's very fitting for teaching people like they're 5. So, yeah, what is hydration? So, it's a server-side rendering initial load optimization. I think a lot of people hear hydration related to web frameworks, and they think, oh, it's like it applies to your whole application. No, it's your server-side rendering your application on the initial load only. Typically, there are some frameworks that do stuff like server components, like you probably heard about that with React. That's a little bit different, but for the most part, most frameworks do hydration. Once you've server-side, your application on your initial load fetches and it hydrates at that point. Once it's done hydrating,
can we just go back? Can we make it even one step simpler just to make sure that everybody's with us? Server-side rendering.
Sure.
What is server-side rendering?
What is server-side rendering? Well, let's talk a little bit about that. So here's your happy little web server. And server-side rendering. So you've got this server that, like if you're running an Angular app or a lot of these web frameworks, most of them, you can just have your JavaScript served from somewhere. It doesn't have to be like a server per se, like an actual application server. It can just be something that feeds out static content. So you get your JavaScript and all of that is fetched and rendered client side. There's nothing on the back end that does anything except for maybe you might call some APIs, but they don't have to be hosted anywhere that's yours. It could be a third-party API. So
that's normal.
That's
everything happening on the browser is normal.
Yes, that is how what we call CSR, or client-side rendered applications, or SPAs, some people, single-page applications. That's how they have worked for a decade. You put your JavaScript somewhere and your HTML page somewhere, and a static server will just spit that out and render your application in your browser entirely. So server-side rendering is essentially where you actually do have a backend server, this happy little web server, that also knows how to handle rendering HTML for you. And that server has a lot more resources and is closer to, I guess, closer to the metal than your client app. It's got consistent specs. So unlike your client browsers, that could be anything from like your fastest AMD Ryzen chip all the way down to like some 5-year-old Android device that was underpowered at the time. So you're not guaranteed that it's going to be the most performant client-side app. So you're going to have different varying performance across the board, but on your server, it's going to be the same regardless. Same resources.
So on the client, and this is really an Angular, not an Angular thing, but this is like a big thing that Angular does, is it's reading all of this code and it's putting all of that into HTML for us, right? And creating the HTML on the fly. So basically the server-side rendering is creating the HTML, taking all the JavaScript and taking all the curly brackets and making those HTML and getting it all ready with the CSS and everything before it even goes to the client.
Yeah, it's essentially reading your application and generating HTML. Now, this slide says DOM nodes. They look pretty tasty. I do enjoy a good DOM node, but in reality, it's actually like, it's not making DOM nodes, it's just making a string of HTML, because when you're passing it over the wire, it's going to be seen as a string. So then you've got your cute, hungry little client web browser that sees all of those DOM nodes, and it goes, I'm gonna eat those right up. I'm gonna render that for you, and suddenly you've got a pretty looking what appears to be a website. However, at this point, it's purely static. All it's seeing is, I've got some HTML, I've got some CSS. This is how it's supposed to look.
I
It
love
may,
this.
it
I love
may
this because
start.
we didn't know you were going to pop in today, and we asked you, please explain hydration like we're 5, and then immediately you're like, I got you, fam. Here we go. I love
Yep.
this.
So at this point, if a user is looking at this page, they'd be like, oh, great. This looks great. It's got an application here. I can start interacting with it. But they can't, because application, what's that? That's your browser right now. It's like, all I've got is HTML and CSS, and it looks like this, but I don't know what you're talking about for application. Then it goes, wait, it looks like there's some script tags in here that has like a path that I need to fetch. So let's place some fetch with that. Let's go, throw out a request, and our server will bring it back to us.
So can I jump in and add something here? Because this, I think, was where we really got into trouble, like out in the wild, because we had Angular Universal, right? And we had Scully. So when it comes to SSR, the way that it was explained to me years ago was SSR is really perfect when you have a lot of static pages, because it's going to get all that stuff ready and it's going to send it to you. It's going to be really fast. But if you have interactive pages, then maybe SSR is not such a good option because it struggles with that. And that is where hydration comes in, right?
Yeah, that's a good way of putting it.
Okay.
So yeah, we fetch that JavaScript, and at this point, well, that application, now that it's fetched, something has to start up. The application has to bootstrap. So, and this happens with like every web application. Doesn't have to be like Angular. It doesn't have to be even a web framework. There is some function that has to initialize for the JavaScript to start doing its thing. So, and then actually this happens outside of the web too. Like, Java has a main function. Every application has a startup process but we call it bootstrapping on the website. And essentially, when that bootstrap occurs, the hydration process has to begin. And that's essentially what's happening here. So the JavaScript is going, hey, I see that there's some HTML there. Now, in the past, what happened is we would do this. We would go, hey, I see that HTML. I'm just gonna like ignore it entirely. I'm going to wipe everything that's there, and I am going to do whatever it is this application says I need to do. I'm going to, go through all of the components. I'm going to render out some HTML. I'm just going to replace what's there. That's the pre-hydration world, which has problems because of Core Web Vitals and whatnot. So,
And Core Web Vitals is a code word for performance.
It is. Core Web Vitals are a series of metrics that are used by like search engines and browsers to determine the overall performance of your website. It's a series of measurements that checks, hey, when your page renders, do things render and then shift? That's CLS, cumulative layout shift. How long is it taking for the biggest piece of your application or your what is the, forgetting the term now, but your biggest piece of content, how long is that taking to show up? We need to know that, because if it's taking too long, that's not great. People are waiting too long to see this. How long does it take for your whole page to fully like render its content? and so on. And yeah, so when you're destroying all of that stuff, that actually delays all of those things, because essentially your browser painted all of it and now it's being wiped, and then additionally it's having to wait till your app renders or finishes fetching and bootstraps and re-renders. So there's potential for shift because it blinks. There's potential, I mean, and then just an overall delay. So all of those metrics are going to take a hit. So the hydration process here is the process of your application going, I see that this HTML is present. What is it? Oh, hey, I see that this aligns with this component that I have here. Oh, and this HTML aligns with this other component. Hey, I know what that is. Oh, okay, I know what you are. It's this meshing together of your application and the DOM that was rendered, that was passed down by the server. And it's a complicated process. It varies between frameworks. For example, React uses virtual DOM, or to do that. And with Angular, we are a template-based framework, so we have to do a whole bunch of annotating of what's present in order to then have the application go, hey, you've got these annotations, let's see what they are. And then it does some DOM walking to compare what it expects to be there with what's there, so that they can mesh up together. So that's essentially what hydration is. And once it's done, you've got a well-hydrated application. Nothing should have flickered. Everything that was rendered by the server remains present. It doesn't wipe anything and repaint anything. It goes, hey, now we're just an active application. So we talked about those core web vitals, the largest contentful paint, first input delay, CLS, and all of these matter to having a measurably performant website. And hydration should improve all of those. So,
nice.
Yeah, that's my children's book rendition of what hydration is.